So first of all, welcome everybody to our review meeting. Today we have a special edition because last week the Gardener Hackathon took place. I think I'm sharing the wrong screen, right? Ouch. Okay. The Gardener Hackathon took place again in Schelklingen in Germany near Ulm. If you want, meanwhile, we have on the gardener.cloud website in the community page here a section for the hackathons where you could look up the events and also get a summary. So for November, the summary will be written here. You can see on the right side the list of all topics that was worked on, a nice picture from the team, some metadata information. The summary is not yet added here, but it will be added in the course of the week. So then you can also see the results. But yeah, it will also be demoed today for most of the topics. So this time I will not go over the agenda because you see we have, I think, 14 topics or so. Everybody has at most 5 minutes. So short reminder to all presenters, please don't use more than the 5 minutes that you have. If you use less, it's good. But we should not take more than 90 minutes overall. Then I would say we get started. I will start with the first topic, which was this one, using self-hosted shoot clusters for single node end-to-end tests. What is this about? So there's GAP 22, which is about creating self-hosted shoot clusters with Gardener. You have seen that in the past review meetings. So that basically means there is no seed clusters. We run the control plane of the cluster inside the cluster itself. So the typical setup where you have dedicated control plane nodes. And here the proposal was actually to use these clusters to basically run end-to-end tests. So deploy Gardener on top of such a self-hosted shoot cluster, make it a seed, and then eventually create a regular shoot. So that is actually also one of the main goals of the topic for now, that we can solve the bootstrap challenge, because when you install Gardener, somehow there needs to be a first cluster. And the goal is that this would be a self-hosted shoot cluster created by Gardener itself. Then Gardener runs there and everything can bootstrap. So let's take a look at the current local kind cluster. We start from the outer boxes and go to the inner ones. So first of all, there is the machine, laptop, where you run Docker for desktop. And there you typically create a kind cluster. So this is how the current end-to-end test for gardenadm looks like. We have a kind cluster. We deploy here the local registry as pods into it. And then we create another namespace there, create these machine pods. So kind is node pods basically. And from there we bootstrap a self-hosted shoot. And if we want to run Gardener or connect it to Gardener, then Gardener runs next to the self-hosted shoot. So not inside, but also in the kind cluster next to it. And there it can connect. So all this is based on kind. And the goal of the topic that we worked on is to get rid of the kind layer. So basically only have the machine with Docker for desktop or some other solution. The local registry would then be run as plain containers within this Docker. And also the self-hosted shoot would no longer run in kind, but directly on Docker. So also as a kindness node container. And then once we have that, we install Gardener into that cluster and eventually also make it a seed. And this way we can basically test this scenario where you bootstrap from more or less nothing, then having a container runtime, to a full-fledged Gardener system. We called this GND, GIND. The pronunciation is not yet fixed. So similar to kind, Kubernetes and Docker, this would be Gardener and Docker, but as said, the pronunciation is not yet clear. Okay, so let's jump to the demo. I have prepared that already. We have introduced a new command, make GIND up. And this basically creates a bunch of containers here. So most prominently the local registry containers that you might be used to, that previously ran in the kind cluster itself. And also this control plane container which is the self-hosted shoot. So if we exec into it and export the kube config at the usual place, then we can see here that there is this self-hosted shoot, and we have all the usual pods. Yeah. And the next step here would be then to deploy Gardener into it. We have also done that last week. It's not part of this branch currently because we have faced some challenges along the way that we first need to resolve. So the current status is that we have opened a couple of PRs here, basically prerequisites to lay the foundation for the setup. Yeah, and those have to be merged first. Also, this one is a critical thing that we discovered, that the resource manager should be split into 2 deployments in the self-hosted shoot case. So when all these things are merged, we can then continue with this topic and yeah, basically introduce the GUID-up, which also deploys Garden and makes it a seed. All right, yeah, that's it. I think if you have questions, please write them to the chat because we don't have time today, or write them to Slack. And yeah, with this, I will hand over to the next presenter, which is Axel, about enriching the shoot logs.
Yeah, hi. Yeah, this topic was about dispatching the Istio access logs to the shoot Valis. We already have access logs in the Istio Ingress pods where we can see each access to shoot API servers, but the logs are only visible in the garden Plutono, so shoot owners can't see them. On the other hand, we have already a mechanism to dispatch logs to dedicated Valis in the shoot namespace. This dispatch is based on the namespace of the pod, but Istio Ingress gateways are running in their own namespace, shared for all shoots. Yeah, this approach doesn't work here, and we actually need to pass the log messages for the destination shoot. So yeah, log messages are collected in the seed with fluent bit. So there's a daemon set running on each node that looks at the log files of the containers, and we have that as input here. Then we have a lot of custom resources of fluent bit to actually configure the fluent bit log parsing, filtering, and that. First, we have this cluster input custom resource that just adds Kubernetes at the file name, before the file name, and uses it as a tag. Then we have a cluster filter. This cluster filter calls a Lua script that uses this tag and adds it to the log record so that it can use B later. Then we have for all components dedicated cluster filter combination that matches the tag and then uses a dedicated regular expression to pass fields in the log messages that can be seen as fields then in Plutono. Then we have cluster output. Cluster output calls our custom plugin that's called Garden Bali. It's in an own Git repository written in Go, and here the actual logic happens. We look at the tag that we added with the Lua script and extract the shoot namespace and push the log message to the dedicated Bali here. Yeah, our first approach was, yeah, all the logic is here in the custom plugin, just hook into that, just add, yeah, just look for the Istio Ingress namespace and push get the shoot namespace from the log message. However, yeah, that was not accepted by the logging team. It's not idiomatic to this whole logging idea with this cluster fluent bit custom resources. Nikki helped us here pointed us to some, had some hints, good ideas, and we reworked it a bit. So now we have a cluster filter for Istio Ingress gateway. Here we call a new Lua script that parses the log message and uses this log message, adds this log message, the path, the shoot namespace passed from the log message and adds it to the tag, so that the logic and the Wali plugin will just work as before, and we can send it to the correct Wali instance and the shoot namespace. So as a demo, I just deployed a shoot with this configuration. I port forwarded to the shoot Plutono, and now I can check for, I can find it was the container name. We have now an Istio proxy. We find Istio proxy here, and we can query that, and we get all the access logs from Istio to Kube API servers. As we use L7 load balancing, we even see the requests here. So I think it's a nice improvement. Any questions so far? We don't want questions, so that's it.
We want, but we cannot answer them here.
Yeah.
Okay, thanks, Axel. Then Garrett would be next one. Allow relocation of backup packets.
Yes, I'm ready. Good morning from Munich. This one is quite short because I think we considered this a fast track. And just yesterday I opened this issue to just receive some feedback from you guys. So if you're interested into this, then please feel free to comment. So to give you kind of a background story to this, when we were migrating our environment with the garden operator, we decided to also move the project at the cloud provider that we deploy our production landscape in, and completely relocated our control plane cluster or our garden cluster. And then we had the issue that the backups from which we restored the existing environment were still pointing to this old cloud provider project. And we actually want to get rid of this old project. So we somehow need to migrate these backups over to the new cloud provider project. And in the seed configuration, and also in the garden operator in the garden resource, it's not possible at the moment to mutate some fields for the backup provider configuration, for instance, region or the backup provider type. It cannot be changed. The credentials, though, can be changed, which is good. And this proposal actually shows a way how to, we can make these mutable. So we wanted to add another annotation to this to secure operators from just changing this by mistake. So we have a prototype implementation here where we added this confirmation annotation for backup change and made these fields mutable. So what happens then when you issue this update request is that Gardener can already relocate these backups without any further changes. So it will just issue another reconciliation of the resource. And during this, the etcd stateful set will be redeployed with a new backup bucket configuration. And then the first etcd pod, it starts up and finds the data on disk. So it can just continue running. And then when it comes up, it will immediately do a full snapshot because it finds an empty backup bucket, and then you have the backup in the new place, and you don't and we don't decide to copy over the existing backups with this copy task. It's just that you have a new backup location, fresh bucket, and with a first snapshot. So this is basically it. If you have ideas to this or concerns, then please let us know. Otherwise, we might try to get this changes here as a pull request.
Yeah, thanks, Gerrit. Next one, Marcel, pulling Gardener node agent from registry mirror.
Actually, I had one concern about the backup bucket relocation. Shreyas,
Yeah, Shreyas, please write to the chat because we don't have the time probably today because of so many topics.
Sure, not a problem. Thanks.
Thanks.
All right. Yes, I'm presenting the topic for Max, who has a parallel meeting. And he's working on an improvement for the registry cache extension. In one of our environments, we also need to go to the registry cache to pull the image of the Gardener node agent. And that use case is currently not supported by the registry cache extension. So we added a new field to the config here called provision relevant, where you can say this is a registry mirror that I also need during the provisioning of a node. And then it will be added to the provision OSC. And in the demo, so I have this shoot for the local setup, and in the extension config for the registry mirror, I added a second mirror config with this new field, provision relevant true. And what this does is, so first of all, what normally happens in the original OSC, if I provide a registry mirror, it goes directly into the containerd config. So in the typed struct here, where the Gardener node agent then configures containerd with these mirrors. But this can't work in the bootstrap phase because the node agent isn't there yet. That's the whole point. So in that case, we need to hit OSC. We need to actually add the files directly. So that would be here. So now the extension adds this file at the right place for containerd to pick it up. This host.toml where we configure this mirror. And then when the init script tries to pull the Gardener node agent image, it will respect this mirror configuration. Yeah, I think that's mostly it. One flyby change that Max also did is to add the option to set a CA bundle for any mirror. So if you happen to have private certificates there, you can now also add your CA bundle here, and it will be added so that containerd trusts this CA bundle.
Cool. Thanks, Marcel. Next up, Konstantinos or Oliver, evaluating Talos as node operating system.
Hi.
Oh, yes, we are here. Hey, good
We are
morning.
here. Yes. Okay. So let's go. So a short introduction to Talos. It's an operating system, but it's designed to run nodes for Kubernetes cluster. The selling point, I guess, is that you can configure the whole node with an YAML. So each node exposes a daemon to which you can push configuration, and then automatically you should be able to get a node that joins the cluster. And this is kind of like the architectural diagram that we get from Talos. So for Gardener, so with Talos, you can get both a control plane, which we don't care in the case of Gardener, and we focus mostly on running Talos as a worker node for our cluster. And yeah, Oliver will show a demo, which will, like during the hackathon, let's say the main effort was spent on trying to run the main components for the Talos control plane. So that is the API daemon and the trusty server. So like we want, like the Talos exposes the Talos ETL command, which you can do like some kind of node management for your cluster. But to do that, you need to have the API server of a node exposed, and then you can do commands like apply your cluster configuration. And the other part is in the control plane. As we can see in the picture, they have this trusty daemon, and the trusty daemon is what manages to combine this this cluster, the Talos machines create a quasi-cluster, and the trusted daemon would establish the trust between the Talos machines, right? So I think it's better shown in the demo by Oliver.
Yeah. Okay.
Yeah.
Okay, let's see.
Let's see.
We used our local setup and tried to enable it for Talos, and we did it somehow the same way as we do it for the local or for the provider local. You see here we have this machine pod for provider local, usually in the control plane namespace of the shoot. And similar to that, we have now the Talos machine pod running there, which runs a Talos image. Additionally, we deployed here this Talos CSR signer, which is what Konstantinos explained before. It's part of this Talos control plane. It signs certificates for the Talos machines. And the other thing, that's the jump host. The jump host is just the thing for us to communicate to the Talos machine via Talos CTL. Okay. So, as you see, we might remember the IP here. It's just copy it, the 68 IP. We need it later. When we check the logs of this Talos machine, it suggests us to use Talos CTL apply config to get it run or get it to join the cluster. And for this, we have our jump host. I jump to the jump host. And I tested it before with the predecessor of the 68 node. So now it's one step back. Talos CTL uses a worker configuration, which is here our worker YAML. And it's a long file regenerated. It describes things like it contains the control plane CA, it contains a token, Kubernetes bootstrap token for kubelet, and many other configuration options. So that's basically the thing, how to install or how to make Talos join the cluster. First, Talos is in a kind of bootstrap mode, so it accepts any commands. You see it here, the insecure command line argument. Yeah, but let's just start it. I started it, and now you see Talos, the Talos pod doing some stuff. It will try to deploy the kubelet now and add it to the cluster. And usually when it's doing logging many things, it works. So let's have a look. Get back to this jump host. Oh, I deleted my jump host. That's unfortunate. Just a second. Let's do it here. Up. Okay, when we get the nodes now, we see there's a Talos machine, and the Talos machine is already ready. There's still some work to do, so it's not yet 100% compatible with our setup, because you see here there are pods running on the node, but you see here this kubectl kube-proxy pod, it's in crash loop back off. Maybe you can see all the pods. Scroll a bit out here. So there are a couple of pods running on the Talos machine now, but the kube-proxy, it's in crash loop back off. And there's some incompatibility during file creation because kubelet is running in a container there. We have a file that's deep inside the kube-proxy knowledge. We have a file called mode. kube-proxy.
So when the kube-proxy starts, it tries to create a specific file, and in the deployment we have it as a volume with file or create option. So basically, the kubelet should either find the file or create a file. However, we have a bug here due to the local setup, and it creates a directory, and that breaks completely the proxy. So we also found an issue about that, but that's just a random, I think. Unfortunate thing.
Yeah, and we can fix it manually to make the cluster, to make the kube-proxy run. I just deleted the directory and created as a file instead. And in case we delete the kube-proxy pod now, I forgot the pod. We will see an entire running control plane, not control plane, an entire running node. So kube-proxy is starting on the Talos machine. Now the node is ready and fully functional. Yes, with only little manual interactions.
Yes.
Yeah.
We didn't finish the full automation on the control plane part, so there's future work to be done. And I think also in the results, we also have documented kind of our concerns or conclusion about the Talos, so you can go ahead and read it, because I think we are short on time.
Yeah, the main difference is we don't have systemd, and we have to replace it by a container API or a container-based interface. But yeah, read it in our nice summary. Thank you.
Thanks. Cool. Next up, again, Marcel, Gardener API types as standalone Go module.
Yes, this is the main topic that Luca and I worked on at the beginning of the hackathon. This actually goes back to a little bit older issue from 2020, where Raphael rightly predicted that we won't work on it anytime soon. But now is soon. We did it. So the motivation was that if you only want to use the shoot type or the OSC type with a controller runtime client, that you don't need to import the entirety of Gardener, and you can just import the API package. A similar move was done by etcd Druid. Back when they did it, this caused problems because this doesn't work so nicely with vendoring. But since we don't vendor anymore, and no one usually vendors anymore, we're not confident in doing this change in Gardener. So we now have a submodule under Gardener package APIs, which contains just the structs mostly. Unfortunately, we had to move a bunch of packages that were also here. There were helper and validation packages in this path, and they imported all kinds of stuff. So we had to move it. That's why this change turned out so big, because we had to change a lot of import paths. So somewhere there's the Go mod file where not a lot changed, but in most files we had to change the import paths. But I can quickly show what this will look like if you have an extension. I did this change in the registry cache extension, which I happen to have open. So as an extension, you of course will still import the entirety of Gardener because you will need all kinds of stuff from there. But then you will also have this new APIs requirement, which will have the same version. Ignore the replace, it's just to demo it. And then a bunch of import paths are changed. So for example, this garden core helper package is no longer under APIs core, which is the new subpackage, it's under API core. In the issue, I already also provided a couple of find and set statements that should migrate all required import paths. So they are here in a comment. I'm not sure if we have a better way to distribute this, but this will save you a lot of work once you update to the Gardener version that resolves this, that uses this. Yeah, I think that's it for this topic.
Great, thanks. Then we have Tobias with the Gardner scale-out test.
Yep, thank you very much. So try to keep it as short as possible. So Sonu, Duke and I worked on Gardner scale-out tests. And basically what we inspired ourselves against were from the Kubernetes entry repo, the hollow nodes, or they call it kube-mock. Basically, it's a concept of mocked kubelets that report, that register themselves with a Kubernetes cluster, and also report all pods scheduled to them as running. And this is basically used for scaling tests of applications with regards to large node and pod counts. And what we tried during the hackathon is to basically copy this concept onto seeds. So so the testing environment for these hollow nodes basically looks like this. We have you have two Kubernetes clusters, one where you run a lot of hollow nodes, or like this kubelets, and they register against like an empty cluster where you then run your test against. So this was the inspiration. What we pretty much did is we took the gardenlet, and we just wanted it to register itself with the garden as a seed, but also it should also accept shoots being scheduled on them, but not really deploying etcd and all of the control plane components, but just report them as if they were healthy. So we basically stripped out everything out of the gardenlet and just kept a few controllers to basically make them look healthy, and basically just patch seeds and status and the conditions. Still let them do the lease renewal. Also patch the shoot status and conditions. So basically the shoot controller. And we also added a custom runnable that should simulate API load of what a gardenlet would do against the API servers in regards to API load, without actually having to run all of the shoot control plane components. As a first test, we took the local operator setup and just put all of the hollow gardenlets in there and registered with the virtual garden that is also running in this cluster. And this basically ended up. So we tested at first only registering seeds. And on an M4 with 48 gigs of memory, we saw that at around 200 seeds, the API servers and all of the control plane components of the garden were becoming unstable. And this is because, memory is not infinite on the local setup. And we observed around 100 megs per hollow gardenlet pod. And this basically meant a lot of memory consumption in the same space where also the virtual garden components are running and all of the garden components. So at 400 seats, it was like a total local meltdown. Nothing could work anymore. And this is basically just resource exhaustion in the local setup. And we also observed that spamming the system with thousands of resources, we also tried to schedule shoots then in a short amount of time. Did not work out that well. So in the next step, we took the recommended kube-mock setup. So we had a runtime cluster, or like a garden landscape, which we just took for testing. And we had another cluster that should just be dedicated to run the hollow gardenlets that then register against the virtual garden. We then took another cluster and created cron jobs that should simulate the landscape slowly but steadily scaling up. So like every minute 50 shoots and every 3 minutes a new seed. And the results of that were that at first the cron jobs were not correctly configured. Sorry, they were too fast, which meant we had a higher scale up than we wanted. Over 10 hours, we registered 800 seeds and around 21,000 shoots against this landscape. Unfortunately, at some point in the middle of the night, things got unstable because probably too fast scaling or not the correct landscape setting. So we basically just pushed out. We did not really look everything too detailed into the landscape setup. We just wanted to get the test out because of time. And yeah, the gardeners could not write their leases anymore. And yeah, so we did not really check everything in detail. So this is also one of our final remarks. So we want to, yeah, basically we need to do it again in a more controlled environment and look at it in more detail. So good things, we did not stumble into any limits where we say, okay, this is some limit for this landscape, you have that limit. It's not really that this case. So we still need to do some more testing and have a lot of things that we also still want to do. So yeah, maybe we can pick this up in the next hackathon. That's about it. Sorry for the short overtime.
No problem. Thanks. Then next up, Tobias Gabriel with the Go Build Cache in Prow.
Yeah, thanks a lot. Shafiq and I looked into how to speed up the Go build and tests in our pro jobs using caching and found quite some interesting things. When we had three things we wanted to improve: the end-to-end time for feedback on pull requests, reducing the overall load on the pro cluster, and doing that in a somewhat secure way. And secure meant for us that, hey, we don't want pre-submit jobs, so pull request jobs, to influence the cache. They should only read the cache, while trusted jobs on the main branch or periodic ones should be able to update the cache. And we first then looked how others have done that. And for that, we looked at both Istio, who are using host path mounted volume across their nodes to cache jobs on the local node. That of course works well if a previous job already ran on that node, but if there wasn't a job, it's a cache miss, but it's rather easy to implement because you just mount a volume from the host. They mentioned in their own discussions that, hey, they have a somewhat low hit rate or cache hit rate. And for our use case, where we have even more volatile nodes and spawning and despawning worker nodes, there would probably be a very, very high cache miss rate. The second project we looked into was the machine controller from Kubernetes. They are using Prow as well as their CI system and have written custom scripts and download Go cache and an upload Go cache script, which pretty much does exactly that. It takes the Go cache and downloads it from a blob store. So they are using some S3 equivalent. And on their main and periodic jobs, they upload a new Go cache. They have some custom logic to figure out which ancestor commit to download for the pull request and stuff like that, which seems to be working quite well for them, but has the disadvantage that if you have a larger pull request or a lot of things you are downloading the directory, similar to how, for example, the actions cache for GitHub Actions does it, where you have a whole directory and download it and upload it. But seems to be working fine for them. And we then looked into, hey, what can we do? And we started to look into mounting and read-write many device. So on GCP, that's pretty much an NFS file system into the nodes. And while that worked, and we saw as well improvements, NFS file stores are quite expensive. And the disadvantage is for pre-submit jobs, you can't use that directly, but rather you have to copy the files from there, and you don't really have a benefit. What we ended up using was a new feature in Go called Go Cache Proc, which allows you to call an external program which acts as a kind of remote cache helper, and that can then store or read the individual cache entries from some place. We used Go Build Cache, so this open source project, to read the cache from our Google Cloud Storage bucket, where each individual build result is cached and can be read from. And the nice thing is using user principles and workload identity federation, We could then use an read-only service account in GCP, which can only read the cache, and a read-write one for our periodic jobs to update them. And we have actually seen quite a lot of improvements across our Pro jobs for that. Unfortunately, we noticed that the end-to-end feedback time didn't really improve, mostly because there's a lot of I/O or waiting on containers starting up, especially in our end-to-end tests, things like that happening. And the other thing we noticed is that while the Go build cache works great, the test cache only works if you have a limited set of test flags specified. And unfortunately, we use the Ginkgo JUnit reporter, and that flag is not supported. So if we want to have nice JUnit tests, we need that flag and can't cache the tests at the moment. But we have still seen some improvements, and mostly during the CPU times. And for that, I can show these two graphs that we have without the cache. We see that the end-to-end tests take quite a bit of CPU usage at the beginning, and overall take roughly an hour of CPU time. And after adding our build cache to it, we went down to just a single 1.5 CPU usages and less than 3 minutes of CPU usage for building it. So we have quite a bit of less load on the build cluster, which hopefully over the long time will as well allow to do more stuff with less resources. And that's it. Thanks a lot.
Awesome, thanks. Then we hand over to Andreas for the MCM machine update topic.
Hi, thanks, Raphael. So Daniel, Aniruda, and I were working on this issue, which we created previously this year in the MCM. The core idea was basically here that in the in-place update flow we currently have in Gardener, the infrastructure resources are not touched. And our idea was that we kind of make it happen that you could also mutate the operating system image of your underlying infrastructure resources. Idea here was basically to extend the driver contract by an update machine interface method, and then the driver could decide if he's basically supporting or implementing it or not. And this one we basically then hooked into the existing in-place updates flow in Gardener. I don't have a demo because it takes too long to process. So that's why the idea is just to explain our story a bit, the trouble we went through. So here basically you can find the commits. We didn't create a pull request yet how the MCM changes look like in regards to the central contract and the in-place update flow. We first, what we did is we basically ensured that this stuff works in the local provider, that this new method is being called. And we basically adjusted after that our own provider extension in Iron Core Metal. So we were dealing here with bare metal machines. And we released all the images of all the forked extensions here and deployed in our landscape. During the test, and actually it turns out that it's actually not that easy in the current in-place update implementation to get to the latest machine image from this machine deployment, machine set machine, and machine class contract. So what we ended up with, yes, we got triggered, the node got basically was selected for in-place update, but in our case, in the machine, the requested machine we received still had the old image. We built a hacky fix to address that problem and could get the new image. We could mutate in our resource. Everything looks fine or looked fine. We then stumbled upon the next problem. The Garden Linux OS extension, which provides the node agent the contract what to do on an operating system level to basically perform this in-place update, expects a tool called Garden Linux update to be present. If that is not present, the in-place update on a node will fail, and the node will be marked as failed in-place update, and we get stuck. What we do, we forked the OS extension. We made sure that, because in our case, where we memory boot machines, we don't need such a in-place update kernel switch. We just reboot into the new image. So that has been done. And then after that, our machine basically image has been mutated, but then we kind of hit the wall. We hit the wall because the node could not rejoin the cluster. Why? Because Gardener node agent and kubelet, of course, were not present on the node anymore because we booted a fresh memory booted machine. Our idea was then, okay, you know what? Barlib, Gardener, node agent, and kubelet, we just bind mount into the host. So we preserve this the content of those folders. But there we kind of experienced the problem that even though we preserve the kubelet and the node agent config, the systemd units are gone. And those we cannot save, at least we have no idea how to do it right now. We cannot save during the boot, so there's no kubelet unit available on the host. But I know that the Gardener colleagues are working on making the node agent more intelligent to basically make sure that the artifacts it creates on the host basically are recreated if they're gone. That might help us. And basically this brings us to the conclusion. So what we thought would be a fast track turned out to be a 1 week kind of struggle. We need maybe to evaluate the in-place update flow. We envision to be, I think, a good way of basically keeping a clean OS on all bare metal servers. And maybe with the help of the Gardener colleagues who are improving the node agent, another idea would be the user data, which we might keep up to date, because the bootstrap token, when it's, let's say, gone and we don't preserve this folders, we need to kind of rebootstrap a new node. But the user data might be like 5 days old or stuff like that. So that's basically our conclusion. Again, upstreamable, I think, might be only the interface part here. But again, we need to address first this hacky trick here, how to get to the new image here. We'll basically get in contact with the MCM colleagues, how to maybe make this contract better. That's it from our side.
Yeah, thank you very much. Next up, again, Marcel, the SIGINFO signal handling.
Yes. Yeah, so this topic was a very small developer or gardenadm developer usability improvement. So the idea was when you run gardenadm, which will usually also happen like an operator runs this command in his shell, it would be nice to get some insights on what is currently happening. So I implemented a new reporter in the flow package, which reacts to a SIGINFO signal. So that would be Control-T on a Mac, or SIGUser1 on Linux, which unfortunately doesn't have this convenient Control-T shortcut. You have to use send this from another terminal session. But just get a Mac instead, and then you can have this awesome experience. I have to copy my command. So I am now started with the local setup with the managed infrastructure use case and just run gardenadm in my shell. And now if I press Control-T, I get this brief output here where I can see how many tasks have succeeded, failed, are pending, and are running. And if there's a running task that has a retry, like retries every 10 seconds or whatever, I would see the last error that happened during a retry, which probably won't happen now, but you would technically see this. So especially for long running tasks, I could be certain, okay, it's currently waiting until this is happening. Because usually we only log when a task has succeeded. Yeah, so only relevant for CLI tools and a small improvement, but if you are impatient with your gardenadm commands in the future, when we will all be using gardenadm initial clusters, this will be awesome. That's it.
Nice. Thanks, Marcel. Great. Then I am next with the load balancer controller for kind. Share the screen. So currently in the local setup, we don't really have a load balancer controller. So this is also documented here in the local provider extension documentation. If you look for service, then you see that the first limitation is that we don't have load balancers for shoots. We have not developed a cloud controller manager. And yeah, for seeds, this only kind of works because of some hacks and tricks here and there. So in provider local, we have this custom service controller that is reacting on load balancer services. And then with some port mappings and forwards here and there, this works, but it's not very nice and stable solution. And they actually, we also, one of the PRs that I had open earlier is cleaning up a kind of dirty hack that we used in the past to make all this work. So we would like to improve the situation there and find a better solution. Turns out that the Kubernetes community has this cloud provider for kind project, which is more or less kind of what we need. So this is a load balancer controller for the kind scenario. Unfortunately here, if you look for Mac, I think, it's is a bit challenging to run this there because unlike on Linux, the Docker for desktop things on Mac run inside a VM. So they are not directly exposed to the host network, and hence all this is quite complicated. You can make it work by running this cloud provider kind as a process on your host. And you can find ways to achieve accessing the load balancer IPs even on your machine. But for us, there is no option because in the local setup, we don't want to have a process running next to all the other things. We want to run everything in a container, ideally in the cluster. And also for shoots later on, we cannot do it this way. So what we have done is to make a small enhancement to the code, and I will demo it now. So as a preparation, I have created a plain kind cluster. And just like we add additional IPs for example, the virtual garden or the Istio and the seeds to the loopback device on the host, we also do this here. We kind of reserve IPs for this load balancer controller to use. In this case, this should be those 4 IPs. Then we can just build the container image for a cloud provider kind, and we can then start it and running it as a container in the cluster. And we provided this flag. This is what we have actually introduced, load balancer IP range. And here we have to specify our predefined IP range that we have already added to our host loopback device. All right, I will start it. We are watching here the processes in the containers basically with Docker PS. So we have our kindest node here, our kind cluster, and there's this cloud provider kind. And in the kind, we currently have nothing. And I will now deploy an NGINX. And afterwards, I will deploy a service. So I expose this NGINX as a load balancer with port 80. And what you can see here is the service. And this cloud provider kind has actually started another container, which is an Envoy proxy for the service. And the addition that we made is that it is basically binding one of the IPs that we have reserved for the container on the host. So now we can use this IP, which is also part of the service status here on our host. And we can happily access this NGINX. And if we expose more load balancer services like NGINX 2, NGINX 3, for each load balancer service, we get their own Envoy proxy container. And the cloud provider kind has a very minimal IPAM to understand which IPs are already taken and assigned unique IPs here. So again, curling 65 works and 66 as well. 67, of course, not because there's no service. And yeah, there's still some open to-dos also with regards to IPv6. And we also have to see if the community is willing to accept such a change, because it actually requires you, as you have seen in the beginning, to prepare your host somehow. Maybe that's a reason why this is not yet supported. We haven't talked to them yet. But ideally, we can use this approach to get rid of this service controller and have a more straightforward load balancer support for the local setup. Yeah, that's it. All right, then we have again Axel, evaluation of the NFT mode in kube-proxy.
Just still used, I think.
Yeah.
No, sorry. Yeah, this topic was also worked on by Benedict, Stefan, and me. There's this nice blog post about NFT mode for kube-proxy. The main benefit is the performance. IP table rules are evaluated sequentially. You have actually a rule for each service. If you have a lot of services, then it takes more time. And if you have really a lot of services, that can really be a problem. For adding rules, it's actually the same. You have to traverse all the rules to add a new one or to remove a rule. So NF tables promises to be a solution for that. We made it possible to configure NF tables with this PR. Before it, there was only IP tables and IPVS. Yeah, now you can configure it for your shoot. And yeah, there's not too much to demo. The evaluation was not too deep, so we didn't test all possibilities of combination of CNI configuration. We didn't make any performance test, but we deployed it with a real shoot on AWS. We didn't see any issues. We switched it on and off. We didn't see any downtime. Yeah, the only thing that I can show is that there are really NF table rules. If I just go to a node and then I can list them. So there are quite a few, but I can show the important part is maybe this map where you have all the services and the cluster IPs, and then they just jump to a specific chain for the service. So this map access is, yeah, everybody can understand that it's quite faster than a serial traversal of all rules. I think that's already it.
Thanks, Axel. Then 5 topics left. Garrett again, replacing Ingress NGINX with Gateway API.
Yep. Okay, so in this track, we were looking into replacing these NGINX Ingress components that are present in a garden seed, with the Gateway API resources. And reason for this is probably because Kubernetes was announcing this retirement of the Ingress NGINX project until March 2026, and they recommended migrating to this Gateway API approach. Of course, it would also be possible to just implement this with the Istio native resources that are already present in the seed. But we thought that it might be a good thing to look into this Gateway API thingy, how far it is implementation-wise from Istio perspective. And also I think it's better approach to follow these application agnostic APIs than the specific application resources. So yeah, we built a small branch for this where we did a prototype implementation for this and only looked into the Plutono Ingress NGINX service. And yeah, here's now the local setup running with this. So first of all, we deployed the CRDs, which are from the Gateway API. And as soon as you apply these new CRDs, so these are not contained in Kubernetes upstream by now, so you need to manually deploy them. But as soon as you do, you can see that Istio, which is present in the seed, of course, is automatically creating these gateway classes. So this just happens magically, which was quite nice. And then you can provide gateways for that. So, and reference these gateway classes. Here you can already see we created for Plutono a gateway. Here's for the seed control plane, and this is for a shoot. And in this, you of course reference the gateway class, but also the existing Istio service, which is here. So reference existing service type load balancer here in the gateway class, and then use the same host name. And unfortunately, you need to place these gateway classes in the same namespace where Istio is running. This is limitation by Istio. So this is in this namespace, even if in our opinion it should have gone into the garden or shoot namespace, but fine. So then next you can create an HTTP route. I can show you this entity if you want to get an idea of how it looks like. So there you can reference a backend service, which is similar to how the Ingress NGINX or the Ingress resources look like. And there you have a parent reference to the gateway. So there with this HTTP route, we reference this gateway here. And then there's, this all works just fine. But now there's like a small limitation or issue that with Plutono we have this basic authentication in place, which we cannot easily get rid of. Getting rid of this is probably another bigger topic, but right now it's not possible to just turn it off or replace it by something else. So we want to maintain that. And this is not as easy as it was before with Ingress NGINX, where you could just annotate the Ingress resource with something. And unfortunately, there's the only way is to use, or that we found viable is to use this external auth API field, which is currently in experimental state and also not implemented by Istio. So what we did to make it happen anyway is that we deployed an envoy filter here, and we wrote also a small external authentication server, which you might remember from being present at some point in the Gardener, but this is now just for dealing with basic hours, and it's not doing anything with VPN right now. And also we don't plan to do it. It was just to realize this basic authentication mechanism here. And with this in place, it was actually possible then to reach the Plutono. So I can also show you that it's working. So here you get the prompt of the basic authentication. When you write something wrong, it blocks you. Otherwise, you can get the password right here and sign into Plutono. So this now works without the Ingress resource in place for Plutono. So we remove this one. It also does not interfere with the shoot. So this works now. We had to do some way of like making this work together, but we found it. So I think there's no big blockers right now which would prevent us from integrating the gateway API into the project. Of course, there's this discussion if we want this, or if we want to do it with the Lua script or whatever from Envoy instead, or do this thing. So there are many ways basically to do it, and this is just one. And other thing would be that in the NGINX Ingress controller, you could also like direct return stuff, which we also do in some routes. Like we are blocking admin API routes and directly returning error codes from that. This is also not easily possible with the gateway API. And I think they also planning to provide something like this. And there's an ongoing discussion on the Istio GitHub repository about this, but this is also not fully supported. So you would either require a dedicated service which can return these error codes, or what we did is just redirecting this to /, which is not so nice because then you don't know what is happening. But if you do this, I can't remember the path right now. Somewhere we edited. We're just redirecting it. This would theoretically work. Yeah. So the outcome is, I think it could be done. Of course, there are many things, many details that need to be clarified, and it will also need to be rolled out gradually. So we need to prepare it, because right now this entire thing was pretty big. So somebody needs to take care of it and slowly do it or introduce it, and then I think it should work. But we leave that up for discussion. I think that's it from my side. I will hand it back.
Yeah, thanks, Gerrit. And next up, Johannes, adding support for Calico Whisker.
Okay, so I hope you can see my screen. Basically, earlier this year, Calico released with the open source edition also some tooling for networking observability. They call Goldmain and Whisker, which basically allows you to capture flow logs and visualize this in a UI. Why is that interesting? Because basically in Kubernetes, we like to use network policy to restrict access to the entities that need access only, so for network segregation. And everybody who has dealt with network policy knows it's difficult to get right. So basically, it's easy to lock yourself out, to have problems with the connectivity and don't see it. What is different here is that while previously Calico components were mostly released via Helm charts, Calico Goldmain and Whisker are only released via the Tigera operator, which is open source, but it's somewhat incompatible how we manage Calico currently. So we basically extracted or reuse the code from the Tigera operator in our extension to generate the resources for Calico, Goldmain, and Whisker. So I have set up here for a demo remote local setup with a small cluster. You can see that you have new components. You have Whisker here, and we have Goldmain here. And basically I'm port forwarding twice because remote local setup to simply show you the UI. So the UI is fairly simple. Let's refresh here. You have your tabular view, which basically refreshes every now and then and shows you the connectivity from pods to destinations. It does not show the IP addresses. It shows basically the pod-to-pod communication, or now you see an update, or basically the communication from private network or public network to a pod and from a pod. So this is all basically allowed communication. We have network problem detector, and then you can also see network policy, so the enforced policy, which policies have we enforced here. Network problem detector tries to resolve something, so it allows communication to core DNS, and this is done by the Gardener Cloud allow DNS policy. So that's all nice, but what we actually also want to see is what if we have a malicious pod in our system trying to, for example, resolve something. So trying to do DNS queries, which obviously fail because we have a 133 cluster and a deny all policy in our kube system namespace. Or if we also simply try to go directly to an IP address, which is the Gardener cloud domain. Again, we will not see a lot because network policy will block us, but we can also, we should be able after some time to also see this basically here in Calico Whisker. It takes some time. Basically, all the flows are they are sent from Calico node to Goldman, and then Goldman Whisker gathers the information from Goldman. So here we basically flow streams are paused. I don't know where they are paused, but okay. We basically see here that the deny all policy blocks our communication going from our malicious pod to the public network. For whatever reasons, my DNS request didn't make it through this time. Maybe wait a little longer. Yeah, so with this, you can effectively see, I don't know, you can see that if traffic is blocked, can see the policy that blocks it, or it might you might see that the policy that allows it, depending on what kind of flows you're interested in. You can also filter it. Yeah, that's what we basically did, and with that, I'm done. We have not integrated it completely. There are some open topics still to figure out, but I suppose we are on a good track so that we could integrate it into the Calico extension and have a similar offering to the Cilium extension with Hubble. So that's all.
Yeah.
Back to you, Raphael.
Thanks, Johannes. Then we have Konstantinos with respecting terminating nodes in load balancing.
I was muted. Okay, I hope you can see my screen. I mean, this topic was not mine, but it was done by Max in his spare hackathon time, and I just helped a bit with discussing the topic. So this is basically an optimization for the deletion of a VM, so that when new connections, so the load balancer forwards connections to the set of machines that belong in the backend of the load balancer. And what we try to fix here is that there can be some kind of delay between detecting that the machine is in deletion and therefore should not accept new traffic, and redirecting the traffic to configuring the load balancer to direct the traffic to other healthy nodes. So we have two ways to delete machines. One is like by the cluster autoscaler, and the other one is when MCM is doing something like a node rollout, for example. And in the cluster autoscaler case, this handle a bit different with the standard MCM deletion. So basically, cluster autoscaler, before it deletes a machine, it uses a specific taint that is a well-known taint in the community, and other components respect the taint, so that, like for example, the kube-proxy and the cloud controller manager, so that they know how to stop traffic from reaching that node. In the case of the kube-proxy, it will fail the health from the load balancer. So like the load balancer in the cloud provider has a backend which has nodes in it, and it health checks the nodes to see whether they can receive traffic, which then the reply is done by the kube-proxy. And if that taint is applied to the node, then we will start replying healthy. And in the case of the cloud controller manager, which controls which set of nodes should belong to the backend of the load balancer, if the node has this taint, then it will just be removed from the backend of the load balancer. So again, in the cluster autoscaler case, before it deletes a node, it will add the taint. So therefore, there will be a little bit of time for the components to reconcile and actually, like, for example, start failing the health checks in the kube-proxy case. So therefore, the traffic goes to new nodes. And this is something that we didn't do in the standard MCM deletion, and this is what gets added here by the PR from Max. So as when the MCM does the node rollout, it will start by doing the node drain, and then eventually we will delete the actual deletion in the cloud provider case, and then we'll delete the node from the cluster. And here we inject a step in between the node drain and the actual machine deletion, that we add the taint and wait a little bit for the components to reconcile. So therefore, at least the detection for the traffic to reach the new nodes should be a little bit faster. It depends a little bit on, like, the actual delay depends on the load balancer settings and how often you're doing the health checks, but at least this should improve the detection time. And that's the PR.
Cool. Thanks, Konstantinos. And two more to go. Luca with using Go tools and dropping VGOPATH.
Yes, exactly. So Marcel and me also worked on at least 2 other parts where we try to improve stuff, clean up the tooling. And this is one of the actions we took for that. So formerly we had the tools that we were using specified here in the tools.go file, so that they are also imported to our Go mod, and we were building them ourselves. And what we now did is we used or made use of the tool directive in the Go mod. So we don't have to build them ourselves anymore. We have this little script that links the binaries. Actually here, we have the script that links the binaries to our tool bin directory where we expect them all the time. And for the tools image that we built for running the tests, we have to actually copy the linked binaries, but this also works. And I guess this is a pretty neat enhancement here. It also means that all dependencies that are using the tools we were formerly building, so if the tools MK is imported, the respective entry in the Go mod also has to be done on the dependency or implementer side. So this is the one. And what we also did is a bit of cleanup. So formerly we were making use of the VGOPATH tool, I would say. So it simulates the Go path as it was formerly required. Especially, so the biggest part was the protobuf cleanup, where protobuf was expecting that the repository is checked out in a Go path in the source directory with the path, and we managed to remove this, adapted the protobuf building, and now this is also clean. But it also means that all extending packages, all dependencies using either the VGOPATH setup script we have in the hack directory or the VGOPATH entry in the make file, in the tools make file, that they have to also swap that out and remove it, as we want to drop it then after Gardener 1.142 has been released. So there's for both of them maybe some action involved. So make sure that you adapt your dependencies accordingly. But then I guess we're here a bit more clean again. it from my side.
Great. Thanks, Luca. And then the final topic for today, presented by Vedran, tool-enabled agent for shoots.
Yeah, thank you. We already had a little bit of tooling that we used through the past 2 years, and now we had enough building blocks to basically put together some agent helping directly with the clusters, and this is what we worked on. So there is something that we already called answering machine. There are some workflows that help, but in the previous time, answering machine was basically only going through documentation and trying to answer questions from that. And we are using Gradio, so it's a functional UI framework. So there's not much that we spent on that. And this is what you can see here. So basically, now there is something that helps with the media that we are using, Slack, GitHub tickets, and I've also created a ticket that I will paste in, and then we will start the process. Wait a second, this is not it. Oops. So it reads the ticket, finds out, reads the cluster. So this is normal technology, no LLM. And then it goes on and tries to answer whatever request the person had in the ticket. So this is a fake ticket, so that hopefully it completes after 1 or 2 minutes. We don't have the time to run a larger analysis. In the meantime, I would show you a few things. We come back to this one here later. Oh, that was very stupid of me because I've now lost it. Sorry. Answering machine. Starting it. Revisiting already done analysis would be, of course, nice. So now new tab. So this morning I reducted a few of the tickets that we answered through the past days, and this is what I'm going to show you here. So I'll show you the live system. So somebody had problems resolving DNS records, opened a ticket, and the nice thing is answering machine is basically looking until it finds something. So in this case, somebody has created a service and simply copied over the definition from one cluster to another cluster. So he was referring basically some completely different domain. Of course, this couldn't work. And answering machine basically analyzed the resources. It has access, basically kubectl access to the cluster, also to the control plane, can also read metrics and logs. And this helps it basically to find what is going on. Of course, you cannot trust the answers. You can trust the data that is retrieved because this is definitely true, but sometimes the conclusions of an LLM are not really all that good. But it's good enough to be used and as a starting point, definitely. This is another one. So here somebody complained about its a load balancer simply gone. And upon analysis, so normally answering machine would answer after approval by a human. I just copied it together because I needed to redact the ticket, everything that is private. And here the problem was basically the Redis operator, which changed the service from load balancer to cluster IP. You didn't have to do anything. You simply use it. It finds out. It tries to analyze what is the problem, and it saw in its data that it has access to. It can invoke tools, as I said, everything that it needed. And the nice thing is also always the reference section, because even if you do not believe this is the right conclusion, LLMs cannot think, they have no intelligence, so sometimes their conclusions are not really smart. You have the links, and these are a nice starting point. And another one that I picked was a reconciliation failure, something with machine deployments. And this was something misleading in the end. What turns out after working diligently, it found that basically somebody has blown up their cluster with 7 gigabytes of secrets. And that was in the end the problem. Secrets couldn't be listed anymore, and therefore everything was falling apart. And again, it's really nice that you get these links into the metrics, into the logs, into the commands. This is quite helpful. You can also answer questions in Slack. So I picked just one. Somebody asked why a certain annotation isn't removed, because it has access to documentations, to tickets, also Slack threads. It knows a lot, can find out a lot. We are using the vector database where we put this stuff in, and we have lots of data that can be used for this. Let's go back to the workflow. Let's see what happened. So this was a very simple case. I basically only asked for what's the status, what is the CPU utilization over the past 24 hours and some logs. With the other tickets you saw, it was doing the analysis by itself. So it was trying out things, it was trying to gather data. In this case, I just told it what to do. But normally the ticket just says something is wrong and it tries to use its tools to come to an answer, what I showed you before. And here there were these three things that I asked it, and it basically diligently worked down this list. So you can use it also as somebody who is doing work for you. And in this case, querying the CPU load, trying to understand what is the status of the cluster and getting some etcd logs, because this is what I told it to do. And then it gives you a summary. You can always edit it to remove nonsense, to add your insights. Maybe you have more context, or you have you're more subject matter expert and want to correct things. So this is only meant as an operator tool. I do not think for a second that we should expose that ever to any end user. But for an operator, it's really a nice thing. And the final thing is basically you can send the answer, and then here is the fake ticket that I created with the job. But you can also instruct it to do things, and then it posts it here, and that's already it. This is what I wanted to show you. So it is an interesting question whether we can somehow share the database that we have, but the general tooling is definitely something that can be also put into open source. And I think it is useful to operators, or can be useful to operators. Thank you.
Awesome. Thanks, Vedran. With this, we are at the end, finally. Quite a lot of topics and a lot of content today. So thanks, everybody, for attending last week and for presenting, and also to all listeners, thanks for joining and staying so long. Two small organizational remarks. Next week, we continue with a regular review meeting. So 1.133 will be presented. And then the week after, on the 17th of December, that's the last review meeting for today, for the last Gardener release of this year, 1.134. And then we will continue somewhere in January. All right, then thanks again and have a nice time. See you next week. Bye-bye.
Thanks. Bye-bye.
See you.
Thank you very much.
Bye.
Bye.